In today's video, I am going to unpack step by step the Arithmetic and Geometric Series. Hi, welcome to my video. Stay tuned. Let's get cracking. What is the difference between a sequence and a series? For argument's sake, let's say you have a sequence 1, 3, 5, 7, 9, etc. Right? How would a series of this sequence look like? It would look something like this. 1 plus 3 plus 5 plus 7 plus 9 plus etc. Right? The difference is the addition sign. Right? You'd remember from the previous videos on sequences, be it an arithmetic or a geometric sequence. This is your term 1, right? This will be term 2, term 3, term 4, term 5. All right, same thing here. This will be your term 1, term 2, term 3, term 4, term 5. Right, so I'm just going to add the addition sign. This will be that. This means a series is simply the addition of terms, right? Let's use an example. Here is the notation of a sequence. Right, we've got a capital letter S. What does it mean? Capital letter S means series. Right? Therefore, we have a small letter N. What does it mean? N means a position of a term. All right? Let's continue. If you have S2, right? What does it mean? S2 means the addition of the first two terms. All right? The addition of the first two terms in a series. Let's expand this even further. Using an example of 1 plus 3 plus 5 plus 7 plus 9 as a series, right? This S2 means the addition of the first two terms. This is term 1 and term 2, right? So the addition of the first two terms, which will be 1 plus 3, right? So I'm going to write 1 plus 3. Okay, so 1 plus 3 gives me a 4. All right. So from this series, I do understand that if I have S2, that means the addition of the first two, right? Because I've got 2 here, right? Whatever number that is here, right, will determine how far I go with the addition in that series. All right. Let's say I have S4. S4 means T1, T2, T3, and T4, right? The last number should correspond to whatever that is here, right? What is my first term? First term is 1, 3, 5, and my fourth term will be 7. And then what do I get? 1 plus 3, which is 4, 4 plus 5, 9, 9 plus 7, which is 16. Now, a series can either be an arithmetic or geometric. And in this video, I'm going to explain the difference. Please, if you haven't watched my videos on arithmetic sequences and geometric sequences, please make sure that you do watch those videos, and they will help you to better understand what we are talking about today. Let's carry on with the arithmetic series. What is an arithmetic series? I'm going to use the previous series to explain what an arithmetic series is. So say you have 1, 3, 5, 7, 9, etc. Right. So remember the first difference, right? So I'm going to say 3 minus 1. This gives me 2. 5 minus 3, 2. 7 minus 5, 2. 9 minus 7, 2. Right? So this is the first difference. The first difference is common. Okay? Meaning the first difference is the same. Therefore, this series is an arithmetic series. An arithmetic sequence can either be infinite or finite. Infinite means when the last term is unknown, right? Therefore, finite meaning when the last term is known. Here is the formula that you will use. Sn will be n to a plus n minus 1 d all over 2. Therefore, for a finite series or arithmetic series, right, Sn will be Na plus L, meaning the last term is known, all over 2. Now, you should make sure that you know these two formulas. Now, how does an infinite series look like? And how does a finite series look like? Infinite series, remember, is when the last term is unknown, right? This is a perfect example. It looks like that. 1, 3, 5, 7, 9, etc. This here, this right here means that we do not know the last term. If your series looks something like this, 1, 3, 5, we know the last term, right? We know the last term. Okay. To explain these two formulas, let's say for argument's sake, calculate S3 for these two series, right? For the first part, S3 using this formula, right? Remember, we do not know the last term. So that is why we use this formula or equation. This is exactly the same as that one, right? Meaning we already know the value of D, right? Remember, the first term, if it's an arithmetic or geometric, the first term, that is A, right? A. The first term is A. In this case, I know the value of A, I know the value of D, right? What is the value of N, right? From here, you can tell that the value of N is 3. All right, the value of N is 3, right? Now let's use this formula. This is 3, 2, what is A? A is 1, right? Multiply by 1. What is N? N is 3 minus 1. D is 2. All over 2, right? Now, 2 times 1 is 2. Now, 3 minus 1 is 2 times 2. That will be 4. All over 2. This will be 6. 6 times 3, 18 over 2. 18 over 2, that is 9. So we did prove that S3 using this formula will give us 9, right? Therefore, let's use S3 using this series, right? We know the last term, okay? So, N, this is the same, but we know the last term. N is 3, right? 3. What is A? First term, which is 1, plus What is the last term? 5. Okay, over 2. Now, this will be 3 times 6. So, 3 times 6 is 18 divided by 2, which is 9. Now you know when to use this finite formula and infinite formula. In the previous slide, we did talk about the arithmetic series. Now, let's talk about the geometric series. So we've got formula number 1, which is Sn A Rn minus 1 all over R minus 1. A condition for this one is you use it if R is greater than 1. Let's go to the second part. Sn A 1 minus Rn all over 1 R. Alright? You only use it if R is less than 1. Say you have a series 1 plus 3 plus 9, etc. Right? So we want to determine what type of a series this is. Now, remember, from the previous videos that I did on geometric sequences, this will be T1 plus T2, T3, etc. Alright? Meaning R is T2, T1, T3, T2. Alright? Just like that. Now, what is the ratio of this series? Right? The ratio would be T2 divided by T1, which is 3 divided by 1. Okay? This will give me a 3. Right? Or you can say 9. 9 divided by 3. 9 divided by 3. This will give you 3. Right? I just proved that this is indeed a geometric series. Why? Because the ratio is common. Right? From these two formulas or equations, you know how to calculate the value of R. For a geometric series, A is always your first term. Alright? A is always your first term. Now, you know how to calculate the value of A and the value of R. Right? Now, if the question says evaluate the sum of each of the following, right? This, right? 2 eighth term. Evaluate the sum of each of the following, right? 1 plus 3 plus 9, 2 eighth term, right? Automatically, you know this is the value of n, right? So as 8. This is what it means to 8th term, right? Which formula are we going to use between these two, right? And how do we know? After calculating or determining the value of r, that will tell you which one to use between these two, right? What is the value of r? R is equals to 3. Is r greater than 1 or less than 1? R is greater than 1, all right? Therefore, we are going to use that formula. What is the value of a? We know the value of a is 1. 1, right? And then what is the value of r? 3. And then what is the value of n? The value of n is 8, right? The value of r, 3. Okay. Now, punch this into your calculator, and the value that you'll get is 3280. Let's use another example. Right. What do we know from this, right? So first thing, I need to determine the type of a series this is, right? So let's check first if this is an arithmetic series. So 2.5 minus 1.25. This will give me 1.25, right? 3.75 minus 2.5. This will give me 1.25. Therefore, this is an arithmetic series. All right. So the first part is done. Okay. If it's an arithmetic series, this is now an arithmetic series, right? What else do we know? We know that the first term, right, T1, is equals to A, right? Now the question says evaluate the following series, right? Meaning calculate the sum of this series. So from term 1, term 2, term 3, this we do not know. This will be Tn. We do not know, right? The term this is, right? Now, we know that this is an arithmetic series, right? As a result, what I'll do is I'll say Sn n a plus l all over, right? The reason why I'm going to use this formula is because I know the last term, right? Now, to calculate or evaluate this series, I need to determine the value of n. I already know the value of a, right? And I already have the value of l, which is this. So this is the value of l, 12.5. Now, how am I going to calculate the value of n? Right? So I know that Tn, remember this is an arithmetic series, right? I know from the arithmetic sequence that Tn is equals to A plus n minus 1 d, right? Do I know the value of d? Yes. Do I know the value of Tn? Yes, I do. Tn, right? So do I know the value of A? Yes, I do. 1.25. So I'm just going to substitute. 12.5. A is 1.25. Right? I do not know the value of n. That's what I'm calculating, right? And therefore, D, I know, is 1.25. Let's continue. Take 1.25 to the other side is minus. So it's going to be 12.5 minus 1.25, which will give me 11.25, right? And minus 1, 1.25. Okay, so divide both sides by 1.25. What do you get? You get 9 this side and minus 1. Therefore, n is equals to 10. Take minus 1 to the other side is 9 plus 1, which is 10. Right. Now I know the value of n, right? Therefore, I can calculate the sum. So this will be S10, right? What is the value of n? It's 10. 10. What is the value of A? 1.25. Therefore, what is the value of L? L is the last number, which is 12.5. Okay, all divide by 2. If you punch this into your calculator, what you'll get is 68.75. Okay, here's the last example. The sum of the first n terms of a sequence is, then they give you an equation of a series. S1 is T1, right? So if I replace 1 here, I'll get 3 into 1 squared plus 2 into 1 plus 1, which will be 3 plus 2, which is 5 plus 1, right? So which will be 6, right? So this is my first term, which equals to A, right? Now we need to check what the question say here. I was just trying to show you what this equation really means, right? So the question says determine the sum of the first 8, right? So if they say, let's say solution, sum of the first 8, right? You already have that as your general nth term series equation. So this is the value of n. I have 8 squared to 8 plus 1, right? Now punch that into your calculator, you get 209. Okay, now same here, determine the sum of the first 7 terms, right? So S7, the value of n is 7. So value of n, 7 plus 1. Put that into your calculator, you get 162. Let's put this into context, right? S8 means term 1 plus, let's say, term 2 plus term 3 plus term 4, term 5, 6, 7, 8. Now, I want to calculate the 8th term, right? I want to calculate this. What is that? The last question says, calculate the 8th term, right? This is the sum. So if it says S7, that means you add all this up until T7. What you get? You get 162. If you have S8, meaning you add all the terms from term 1 up until term 8, then you get, but I want to know, what is this term, right? How do you get to term 8? How do you determine the value of term 8, meaning T8? Term 8 is S8 minus S7 all the time. This is what you must know. Tn is equals to Sn minus Sn minus 1. This means if I have T2, right? My n is 2. This will be S2 minus S2 minus 1. Where I see n, I put that value of 2, right? So this will be S2 minus S1. Okay? Meaning if I want term 2 here, that term 2, right? I need to calculate S2, meaning take that, put 2, 2, right? Then get the value, and then also calculate S1. Put 1 here, 1 here. I already know the value of S1, which is 6, right? And then I'll be able to get T2, right? So in this case, we already know the value of S8, right? Which is 209 minus the value of S7, 162, which will give you 47. If you have watched up until this far, thank you so much. Please make sure that you watch my next videos.